Why doesn't the soil temperature change around the exchange pipe and the efficiency drop? Michael.
Question. Uh, Actually, yeah, what happens in the closed loop system, yes, as we extract heat out of it, the temperature will drop around the pipe. But what also happens as we get some rest and recovery, the earth will recover back around that soil. So again, as we go through the whole season, yes, the entering water temperature from the closed loop system will drop, but we still have great efficiencies out of that. One thing, depending on the loop type, in for instance a horizontal loop, the top 20 foot of the earth, there is surface swing. So the deeper temperature that we refer to there is some swing as you go deeper, it gets less and less. Once you get below that 20-foot mark, it's consistent. So in a vertical loop, but again, as we extract that heat, it is going to drop the temperature of the loop. But again, we still get great efficiencies out of it. And then as the unit cycles, Mother Earth recovers around that loop. So hopefully that answered your question a little bit.
Can a water well be used as a heat source?
Great question. The answer is yes, but it needs to be quantified. And when we talk about a water well, typically that would be what we refer to as an open loop system. We didn't really get into that in this thing here, and there are some stipulations in different areas whether or not open loop can be done or not. Where we basically run well water through the heat pump and then discharge it back into a discharge well. So possibly another discharge well would have to be drilled in that scenario. But the other big thing that needs to be checked out from a good qualified contractor would be, with an open loop system, we need to have quantity of water from that well. And generally that well is also supplying your water for your home. We need to make sure it can supply amount of water also for the heat pump, but also water quality. Just because it's technically drinking water, a lot of gallons of water are going to run through that heat pump, and we got to make sure it's not going to do damage to the heat exchanger or create excessive amount of maintenance, where the heat exchanger has to be cleaned very, very often. So all those things would have to be looked at if that could even be a possibility. So again, it's going to be a kind of a case by case, but the answer is yes, but it needs to be quantified.
How do you achieve 125-degree hot shower water when the temperature in the soil is only 55 degrees, Mike?
Again, another great question. Again, it's through our refrigerant cycle. And basically, what we're doing is we're extracting heat out of the ground. And even with, 30-degree water, it's still, we can get a lot of heat out of that water. And we extract just a few degrees out of that water. And then we can compress it through the refrigerant cycle. Like you saw earlier in an analogy, our refrigerator. So we're using a refrigerant cycle, and we're compressing that refrigerant. Well, when we compress that refrigerant, it becomes a very high discharge hot gas. We pass that through the heat exchanger and then put that into potable water. And in the case of like the Trilogy unit we were talking about, it goes directly into a hot water heat exchanger that then again we put right into the hot water tank. So again, that's through the refrigerant cycles how we're able to get those kind of temperatures.
Great. Do you still need a backup heating system in case of extremely cold weather?
Uh, Again, the geodesigner analysis will tell you. You saw that example there where the Trilogy machine, in that one case that we had there was no backup needed. Now, and again, in a cold climate, I would still put in these units. Typically, we have backup electric heat coils that I would put in there, just if nothing else, for emergency cases, in case something was to happen and you had to go into emergency heat, so that again you have backup heat source. But in most cases, we won't use a lot of auxiliary heat with a geothermal heat pump, because again we're utilizing the earth, whereas on an air source heat pump, as you get into these colder temperatures, the capacities drop considerably. Whereas in a geothermal heat pump, we don't drop near as much because, again, our water temperature doesn't drop as far as what the air temperature does. But also, we can move heat out of a water a whole lot easier than we can move heat out of an air. No different. A little on that quick analogy would be if I stick my hand in 32-degree water, I'm not going to leave it in there very long. I have my hand out in 32-degree air. Yeah, it's cold, but you're not. You don't need to run for the glove real quick. You know what I'm saying? So that water, transfers those BTUs very quickly. So again, that's one of the other advantages of geothermal technology.
What do you do with your old furnace then, Mike?
Well, the old furnace can be, in a lot of cases, taken out, and say a packaged geothermal heat pump go in, and it's like in the case of like a Trilogy 45 machine, and so again, that old furnace would just be recycled, through metal scrap yards. Now, the other option that we do offer split systems. So in some scenarios, they can be dual fuel, so that you could have, backup heat with, say, a fossil fuel furnace. But again, a lot of cases, there's no really need for it. As you saw in that example we ran, no backup heat needed. So why would we leave the gas furnace in that particular case? So.
What's the impact on the home's resale value?
Uh, Generally, again, it goes up. It's been my experience over the years and dealing with customers for years and years on geothermal, and myself as a contractor in the past, talking to folks, and even myself, I'm a consumer, if you will, of geothermal products, and I'm heavily involved in geothermal, so I walk the talk. I got it in my own home, and it increases the value. So as you talk to realtors, typically if there's geothermal in the home, I mean that's an incentive. That loop on the ground is, it's a power plant. We're moving energy to and from that earth. And again, that loop in the ground is going to be there for a long period of time. I mean, it's the life cycle that they've had on that pipe and things like that. It's many units are going to get changed out, and still we better utilize that same ground loop again, as long as it's properly installed for that home.
Yeah, so depending upon the homeowner, most homeowners are smart enough to calculate that, gosh, I get this home over here, it's costing me $4,000 a year for my oil and my hot water and my air conditioning, and then I got this other home over here, and it's costing me $1,500 for all of that. Jeepers, I can save over $2,000, maybe $3,000 a year, and over 30 years. Gosh, I got a lot of money I'm going to be saving. So of course, I'd be willing to pay a bit more for a home that has less energy costs compared to other ones. Not to mention the comfort benefits. So, great.
Just the green technology, like I said, the carbon footprint and just doing a better thing for the environment.
Yeah, another reason people are willing to pay for green, but they're even willing to pay more when it's saving money, saving green at the same time. So go clean, save green. How does tree shade influence things, Mike?
That's a great question. As far as tree shade on the home is a great thing as far as in the summertime for our cooling loads. But as far as the loop, I assume that question was geared more towards the loop. That has no effect. We have no problem whether we're in a shaded area. A lot of commercial applications we're under parking lots with loops. In some cases, we're under buildings. You mentioned that apartment building, the loops are under it. I know of a lot of projects where vertical loops are underneath the building. So as far as influencing Mother Earth, temperature there, being in a shaded area, wooded lot or something like that is not going to impact the efficiency or the benefit of, being able to pull that energy to and from the earth.
Somebody said that they got a call from someone who said that everything they need for their house to use their equipment can be done by them doing it over the internet. They don't even have to come and do any sort of assessment. You talk about that. How's that possible?
Well, I would be very nervous about that. You might get a pretty wild ballpark, if you will. But this is a big investment, and again, we want it done right. And so the best thing, again, every house is different. I mean, we can get on Google Maps and things like that and do kind of a analysis. There's load programs out there that can give you a ballpark, but again, they're taking assumptions. So they're taking assumptions based on the age of the home, what the R values of the insulation are, things like that. Whereas when a qualified contractor comes out and really does a manual J load calculation, like I've done for years on homes, I'm peeking my head up in the attic. I'm looking at the insulation. I'm looking at the walls. Are they 2x4 walls, 2x6 walls, all these kinds of things. Maybe the windows got replaced. That can make a big difference. So all those things go in there. Or again, if you're just doing it online and not really seeing the whole thing, you might find out that they have pretty bad windows that have a lot of leakage, so the heat load is much higher than what you would anticipate, and so it becomes a very a dicey thing if you base it all on that and don't quantify it by going out to the home and doing a true analysis and then run it through our GeoDesigner program. Very critical after we do that load calc. So again, by just doing it, without ever visiting the sites. Personally, myself as a dealer in the past, I would never do that. It would just be, it could be a very, you end up with a lot of unhappy customers. So I would not recommend doing it that way at all.
Okay. Why do you use a refrigerant? Is it similar to Freon, and are there any risks if it escapes?
Good question. No, we're utilizing now, HFC refrigerants, which the whole United States is. We are moving towards some other refrigerants down the line, but right now we're using R410A. So there does not have a ozone depleting factor like R22. There is a slight global warming impact with a lot, leakage of it. But again, a lot of times in our packaged geothermal heat pumps, these are sealed from the factory. We don't have lines that have to run between an indoor and an outdoor unit like conventional air conditioning or air source heat pumps that rely on field, brazing and things like that. So with our factory controlled system, it's more like a refrigerator that you purchase, again, with HFC refrigerants that are in those. It's a sealed, they don't hold as much refrigerant. So again, that's also a benefit with a packaged geothermal heat pump. But again, down the road, the whole industry will be moving to some other refrigerants that'll be less global warming impacts. But again, right now, the whole industry here in the United States is using R410A. We have been for several years now. Again, very safe refrigerant. It's not going to cause anybody to get sick or anything like that if it was to leak out into the home, or if there was some kind of a situation like that.
All right, so how about a horizontal loop in a high groundwater table? Is that desirable?
Yes, actually, horizontal loop that's in a saturated soil would work very well. As I just mentioned my analogy a little bit ago with sticking my hand in that water, how well that transfers BTUs. Obviously, in a saturated soil works very well. I will tell you that, again, that really needs to be looked at because depending on those soils, how feasible is it to get it installed, I guess, depending how saturated it is. So again, that would be something to definitely talk with your contractor, depending on what, if it's kind of a swampy area, if it's going to be feasible to about to dig trenches in there or not. So again, it just kind of depends on the situation, but the more moisture content in the soil, the much better the heat transfer to that point.
And of the four different styles that you've shown, the horizontal, the lake, the direct ground, etc., which is the most efficient? Which is the best one to have?
That's a great point. Really, all of them are can be the same efficiency as long as we model them in that GeoDesigner software. And what it's going to do is it's based on the load of your home, the piece of equipment we pick. It's going to dictate how much pipe we have to have in those different configurations at the depths that they're at. All of them are going to be within about $20 a year in operating costs from one another. So I always say in my training classes, there is no best loop. It's the best loop is the one I can put in for that customer for the least cost and still provide them with that efficient system. So again, if there's a pond on the property, generally speaking, that's one of the more least uh, cost loops to install, because we have to excavate to the pond, and then the working portion of the heat exchangers in the pond. So, but again, if they don't have an adequate pond on the property, obviously we can't go that route. Vertical loops, in at least most markets, are one of the more expensive loops to put in, just because it's very expensive equipment that it takes to drill those holes in the earth versus horizontal loops. So if we got a lot of room and I can dig horizontal trenches, and I'm not getting into a lot of rocks and other things that can impact the pipe, then that can be a more economical loop. So again, to answer that question, there really is no one best loop. The best loop is the one that fits your property, that I can put in for the least cost, and it's still going to give you that ultimate efficiency. But the key is, modeling a GeoDesigner so that we get the right amount of loop in the ground, not just some rule of thumb.
Great. So with geothermal systems, is it still good to use a setback thermostat and keep a cooler temperature at night, or vice versa during the summer? I mean, what's the story there?
Again, great question. And then obviously there's a lot of difference of opinions on that topic. So I will tell you, with all my years of experience, and quite a few others agree with me, I believe, in the industry. When with the ground source heat pumps or heat pumps in generally, best thing is find a temperature you like and leave it there. You're going to see your best savings doing that. If you do a lot of setback, at least of any significant amount, say you set it back 10 degrees at night or something like that, you're not going to see savings. You're actually going to, because now we got to catch up. So in the morning, when all of a sudden that thermostat has to catch up, we're really going to be taxing the loop and taxing everything else. These units do a great job once you get the temperature you like to maintain it at a very high efficiency, and you're going to see your best savings there. The other thing with that, with for instance, our Trilogy 45, again, we make hot water. Well, if we do a lot of rapid swings in temperature, we could get into scenarios where it's very hard to produce our hot water, and because there's such a high demand on either heating or cooling, because we're trying to come out of a large setback. And thereby then you're not going to see that hot water savings, because you're going to be running the backup electric elements that are in the tank. So, setback, whereas a lot of folks out there will say that, that you can get a lot of savings there. Not so much, again, with heat pumps. I think you're better off finding a temperature you like, leave it there. You're going to see the most savings. I can tell you from dealing, again, with a lot of customers over the years from my own business in the past, I've had some in the past, hey, I'm sending back, I'm getting higher bills. I finally convince them, just find a temperature you like and leave it there. Usually they'll get a call back, or when I get back with them, yes, that I'm, now my bills are more where they should be. So again, there's definitely, with these systems, I think you're much better off. Find a comfortable temperature you like and leave it there.
So
on vacation for a long period of time, there might be an advantage to set it back and then turn it back up. But on a daily basis, no.
Right. But if somebody wanted to do it at night, so because they like it a little cooler at night when they sleep or something, they go down a couple degrees, it's not going to have a big impact, right?
No, a couple degrees. And again, that's the advantage. Also, you can add, again, work with the contractor. A lot of cases, possibly can add duct zoning, again, with our equipment, to where you could have your master bedroom or your bedrooms on a separate zone, so that at night you could turn those down a couple degrees, where a lot of folks do like to sleep in a little cooler environment. So that's something that can be looked at and addressed, again, with your qualified contractor.
So I have an open loop single standing column well and a Climate Master Tranquility unit. While it may be too soon to replace it, I'm curious to know if the Trilogy 45 will work with an open loop system, or would I need to install a closed loop? He likes the sound. They like the sound of the variable speed operation versus the stage 1, stage 2 setup that they have now.
Great question, and glad to hear another fellow Climate Master user out there. As far as the standing column, though, right now the Trilogy 45 is only designed to work with closed loop systems, so it would not be able to be directly applied to that open loop standing column. It would have to go to a closed loop system. So again, you would have to have a contractor involved to see what it would take to go in, possibly by to use that one standing column hole that's already drilled and put a vertical loop in, possibly. And then drill possibly additional holes, depends on the depth and things like that. But we cannot run well water directly through the Trilogy 45 machine, and it's a closed loop system. So again, I would definitely get a good contractor involved to take a look at that and analyze it, and to see what it would take to on your particular project to bring that into a closed loop. So
okay.
Reach out to us if you need any help with that, whoever that.
Yeah, get somebody to take a look at it, right? Again, free estimates, right? All right, so can I use my existing heating vents to force hot air, or would they need to be replaced?
Great question. In most cases, you can utilize the existing ductwork. Again, if it was properly done to begin with. But again, that to that point earlier about just looking at something on the internet and then giving a price, that's another important thing that goes into having a qualified contractor come out and look at your home, is to evaluate your ductwork to make sure, again, we're getting the delivery of the air to the rooms properly. So in most cases, yes, the answer to that question is the existing ductwork in most cases, if done properly to begin with for conventional forced air systems, will work very well also with geothermal. But if something wasn't done right to begin with, you got rooms that don't heat or cool properly and things like that, then that maybe some of those things need to be addressed, and maybe that can be, some ductwork can be updated, if you have those problems in your home.
Yeah. Question got to ask if they have some baseboard heating in addition to the heating vents. What happens with that baseboard? What happens in those areas?
That's a good question. Obviously, I assume they're referring to hot water baseboard.
Yep, hot water baseboard. Sorry. Yep.
Hot water baseboard. We do have water to water geothermal products, and again, generally speaking, water to water geothermal products don't get to the high temperatures that are needed for hot water baseboard, but we can do radiant floor. One thing that we can also do is we can do a water to water, and then with the geothermal, and basically heat the water, say to roughly, let's say 120 degrees, and then from there use a boiler just to top it off to get that additional little bit that needs to go to, like, say 140 for the hot water baseboard. So again, getting a good contractor in there can look at those needs and see if the baseboard is still desired to keep versus going in and putting in ductwork and things like that, or like I say, possibly could go to radiant floor type scenario where we can run much lower water temperatures through and still deliver the BTUs. So there are some other baseboards out there too that will run with a little lower temperatures, so possibly can replace those baseboards with those that can achieve the radiant baseboard at a lower delivering water temperature. So great question. So again, we'll need to look at that specifics there of that job.
Somebody has hot and cold spots in their house. Will this system take care of those?
Great question, and the answer is there's a good likelihood because the geothermal heat pumps that generally run longer and circulate the air. A lot of times they might, but again, we really need to have that contractor look at it and see, is it a duct delivery situation? We don't have enough duct in that room based on the load of the room. There also might be some scenarios there with, maybe we thought a portion of the ceiling was insulated and it's not. I've run into those scenarios where, again, proper looking at some of those things, crawling around the attic, things like that, seeing that something's missing that was supposed to be there. And a lot of those scenarios, those cold rooms, sometimes that's what it is, or there's a lot of air infiltration that can be sealed up so that we can make that room, more comfortable. So, that goes, I could just tell myself as a contractor in the past, you had to look at a lot of these. You had to kind of be a detective when you'd go out to a new homeowner's home, and you were going to put geothermal in or whatever you're putting in. You really need to look that home over and because again, if I always ask the question, do you have any hot spots or cold spots? That's just what this guy asked here. Very important, so that again we could try to address those or find out we can address them. So that, again, the best thing is to ask those questions so that again you don't have any doubts of what that system's going to do.
So if somebody has an existing geothermal system and they want to get a new one or upgrade, what can they still get the tax credits and such, or what happens there?
Yes, yeah, you still can get the tax credits, the federal tax credit for sure. You can still get that. Again, it's just obviously going to be on what the replacement cost of whatever that system is. So yes, you can still get that federal tax credit. I'm not as familiar with some of those local incentives there, but you might better answer that one, Ron, as far as some of the other benefits from some of the local incentives there. They can still utilize those on a retrofit.
Yeah, I mean, I think I believe so, but definitely, again, check with you, get a contractor, get a free assessment, and double check with the utility, because I hate to say it, but each utility has their own little understanding about that question, and a bunch of others too, for a matter of fact. So yes, indeed, it's an interesting point for sure. What restrictions, if any, are there to installing a ground loop or boreholes on a property within a Fema flood zone?
That's a great question. I honestly don't know for sure on that one. We'd have to probably get a hold, and that whoever that is, I would recommend, again, get a hold of a good contractor, and then in turn talk to the driller who would be doing, typically the vertical loop install. Drillers are going to have a much better knowledge of, of some of these situations like that, if they're able to do that or not. So that's a good question. I honestly don't have the full answer for, other than research it first, obviously.
With the radiant floor heat, does the system automatically valve it off when it's in the cooling mode?
The system, when is set up like a water-to-water geothermal system that I referred to earlier that does radiant floor, yes, it will shut off the radiant floor during the cooling mode. And these water-to-water units also do chilled water. A lot of times we send the chilled water then to a fan coil that then has ductwork in it in order to cool the home. So again, depending on how it's all set up, we can do again radiant floor heating, which is very, very comfortable heating, and then do chilled water cooling off of the same geothermal unit.
So how long does it take to install these things, Mike?
Again, it will. I hate to always put it at it. It will vary job by job, but if it's a retrofit, generally the loop is, again, depending on what it takes to put that loop in. That may take that's going to be one portion of it, and then the actual, say you're doing a retrofit, taking out an existing unit, putting another unit in. Typically, putting the actual unit in is done in a day or two. If it's a retrofit. In most cases, but again, every case is a little different. So I don't want to just say that's a hard, fast thing. And again, the loop, again, depending on the size of the loop, and what they're up against. That might be 2 or 3 days, to get that loop in, depending upon again what those conditions are. So generally speaking, it's approximately a week, but don't hold me to that. That it's going to vary again a little bit case by case, and that's where again talk to that contractor, and they can give you a better idea exactly, for your particular situation, what that's going to entail. Because again, if we got to do a lot of ductwork renovations and things like that, obviously that's going to add to that time. And if there's any, weather things and things like that, obviously they can add to that time as well.
Yeah.
I speak as in my area here in Indiana, when in the past when I did retrofits, a lot of times there was a day or two for the loop, and then a day or two, to replace the unit. So, and it was done in stages. You got the loop in first, and then you went back and changed the unit out, pulled out their existing system, so they didn't lose any comfort for any length of time.
Great. All right. What about code and inspection challenges? How does that work? And does it vary by town or?
Oh yes, there can be some variations by towns and cities. But generally speaking, it's going to be much the same as far as any conventional heating and air conditioning system, as far as any codes. The only other thing that plays a little bit into effect is the loop. So it just depends on that municipality. What they might sometimes they want to see the piping and things like that as part of the inspection. So it's just going to depend. Where I'm at here, for instance, just to give you my example here in Indiana. Any of the inside portion of the system, again, is inspected just like any other conventional system as far as the ductwork connections and things like that. But the loop itself, there's no inspection on that part of it, from any of the municipal, city inspectors.
So can you put a loop in a town sewer?
No, I mean that's kind of a wild question, I guess. Obviously, when you talk about, I assume they're just talking about a sewer pipe or something like that.
No. Like the town. Let's say you live in a place, you got a town sewer system out there. Can you just put a loop out there and suck the heat out of the town sewer? Just use that as your loop, not as your loop. Put your pipes into the town sewer system.
Generally, probably the answer would be no, but there are, I will say, there are some sewer facilities that are actually heating and cooling their facility with closed loop systems that are in, some of their sewage treatment ponds. But generally speaking, for a residence to then tap into the sewer and somehow, that's probably not going to be feasible in most cases. So again, that'd be a wild card case, if you will, that somebody could do that in their own residence, tapping into. So I would generally say no, but obviously a case by case. Like I said, I know we got some pretty nice, unique situations out there where some actual sewer facilities are doing that thing, and water treatment facilities. I just visited one down by Cincinnati that the water treatment, they've got these large water tanks, and they've got basically pond coils, and the water is flushed in and out of those tanks, several times a day just from normal. And so they're taking advantage of that in order to heat and cool their facility. So a great way for their facility, but not, an individual residence around there.
Yeah, so it's more on a community basis or a municipal basis as opposed to a residents doing it, and I could see where it would cause all sorts of issues, but including having town issues with the municipal sewage system that they would want you to mess with. But great question. It's really interesting. So what do you do with your old oil tank that someone's in the basement, but if it's in the basement or the yard, what do you do with it?
That's a real good question. Obviously, it needs to be disposed of properly, so you really need to check with your locality. Obviously, in most cases, it can't just be cut up and scrapped without being cleaned out. The any residue or remaining oil. So obviously, any remaining oil, you want to get as much of it pumped out as can be possibly pumped out, and possibly can be sold back. You'll have to again check with your oil provider. if that's even a possibility. But again, you'll probably again need to probably talk to your contractor in that area that find out the best way that they in your particular area how we can safely get rid of that tank.
Can you just keep it there?
In some cases, yes, you could just keep the tank. So again, it's not necessarily something that has to be disposed of right away, but obviously at some point in the life of the home, it probably will need to be addressed in case rusting out, things like that.
Does Climate Master make a pond loop heat exchanger? If not, do you recommend one that is more efficient just to put the coils in the water?
Yeah, generally speaking, I mean, Climate Master does not make actually any of the heat exchangers themselves. In most cases, it's done with polyethylene pipe, and we use basically a 3 to a 500 foot coil, and we space it or we'll fan it out kind of into a slinky pattern. And when we install these in the field. Now there are other types of heat exchangers out there. They get a little more expensive, but in some cases they make sense. Some of the stainless steel plate heat exchangers and things like that. But generally for residential and a lot of these small ponds, I've done a lot of them here in northern Indiana in the past. Again, I've used polyethylene pipe and just have a space coil. So there are places that will sell those space coils to the contractors so they can build those up. And generally speaking, the polyethylene pipe is a little more reasonable upfront cost, definitely, than versus some of the other heat exchangers that are used in ponds and lakes. But in some scenarios, those other heat exchangers make a lot of sense when we're trying to go underneath a permanent dock or something like that, keeping it in a very confined area. So again, case by case on some of those, it's very important that in order to get you the best thing that's going to get you the most benefit for your buck.
Bang for the buck.
Yep.
All right. They looked at the website and they want to know, is a variable speed system better than a two-stage system?
Hands down, by far, absolutely no contest. How's that for an answer? I live with a single speed geothermal heat pump for 21 years, and Climate Master offered to, field trial the trilogy. So I took out a perfectly good operating heat pump after 21 years and, dismantled it and recycled it. And I put this in here, and I got to tell you, I was comfortable. I wasn't unhappy with my electric bill because, again, I'm all electric. But when I put in the Trilogy variable speed, I didn't really understand what comfort truly felt like until I had that in here. The temperatures just were so even. The fan runs a lot, but it's at a very, very low capacity. It's just kind of idling. It just ramps up as it needs to for those conditions. So, yeah, it's a big, big difference. Also, I was able to kind of play around a little bit and fine tune as I needed for the comfort in various parts of my home by going over to my thermostat and adjusting my airflow. That's how easy it is. So leagues ahead of that. And certainly the comfort warrants it, I will tell you.
So here's somebody that's got a home on the top of a mountain and it's really cold. It gets down to -20 sometimes for a few weeks. They've got 900 square foot on one level, 1,750 on their main level, and then another 1,750 square foot basement that they're heating. Currently have a boiler, an oil boiler. We're running hot water to 2 air handlers. They got an 18-foot ceiling that drops to a 9-foot ceiling and a slope. What will it cost them? How soon can you start the job? And the first piece is, what will it cost you? Get a free assessment. Get these guys to come out. Let them look at your particular situation. Let them run the numbers about where you're at now and tell you specifically for your location, the type of drilling they have to do, the opportunity. You have a pond, don't have a pond, horizontal field, vertical field, drilling, cost, type of rock, etc., how much integration with your existing system. Get a free assessment. That'll give you the number that you're looking for, and then you can talk to your accountant about the tax credits, and they'll also, obviously, Bell will run you the incentives and how much you'll get out of Central Hudson. And in your case, it sounds like you'll get more than the average $10,000, so that comes right off the top. There'll also be financing packages available for you. So so there you go. Another question. So I got solid rock. Is that good, bad, not good? How you gonna put in a geothermal system with solid rock underneath me?
Hey, that's a great question. Actually, rock is a great thermal conductivity as far as moving energy to and from, as far as the earth. It has a very good high conductivity rate. Just think about, you have a rock that sits out in the sun. If you go out there just after the sun goes down, you touch that rock, it's still hot or warm if it's been out in that sun. So it can store and transfer quite a bit of energy. So, a vertical loop, obviously, if we're in a rock area like that, it's going to make them go out probably the only sense as far as installing the loop. And again, people typically drillers that are in that area, they're used to drilling in rock, so it's not usually going to be any kind of an issue. They're set up for whatever that kind of rock formation is, and we're going to drill that hole through that rock. We're going to put that U-bend in, then they grout that hole, so we got conductivity between that pipe and that rock, and that's going to be a great performing loop.
So one of the things that I understand is actually rock is great, but sandy soils not so much, because when you're trying to drill into sandy soil, it keeps filling in the hole. Is that
Well,
about right?
you can have that. And the other thing with sand, depending upon the saturation level, you just think about, water moves through sand. So unless it's staying there, dry sand doesn't have a very good conductivity rate, but moist sand, would. But as you said, trying to drill in there, generally they've got to put, in the top layer, if you got a little layer of sand, they usually have to put some casing in order to hold that sand back. When they're drilling those vertical loops. But yes, that can definitely be a lot harder to drill in than rock as far as keeping the formation.
All right. So one of the things folks should know is that in New York State and many other states, but in New York in particular, you can go down 500 feet without getting additional permits. And that 500-foot hole just under the footprint of any building, whether it's a small home or a large home, those 500-foot holes, when sized properly, can handle the heating, cooling, and hot water for a building up to 25 stories or more. So that power of the earth with just those 500-foot holes can heat, cool, and hot water for any building, any home really, and any building up to 25 stories. It's being done all around the state. So it's a pretty incredible technology. And for those of you who know, St. Patrick's Cathedral in Manhattan is actually heated and cooled in hot water from a geothermal system where they drill 2,000 feet into the bedrock under Manhattan. So if you want to see a really cool geothermal system and you're in Manhattan, decide to go by St. Patrick's. Amazing, amazing technology. Another question. What happens if there's a high water table?
Actually, that can be a good thing, actually, because as I mentioned a minute ago about with this the saturated sand, it's a better conductivity as far as moving heat. Just one real quick analogy. Just think about it's 32 degrees outside today, and I put my hand out there. Yeah, it's kind of cold. I have my hand in that 32-degree air. I go to stick my hand in water that's right there at the freezing point. I'm not going to leave my hand in that water very long. If you've ever stuck your hand in some ice cold water, you don't want to leave it in there very long. It's going to go numb on you. It's moving that heat that much faster than the air. So it gives you an idea the power of water as far as moving BTUs. And so having a high water, again, as long as the driller can deal with that when they're drilling and keep that hole open, which there's, again, a good driller out there has a lot of different ways they can do that with different mixing of drilling muds and such in order to keep those holes open. Moisture in that hole is a perfect thing.
All right. I've heard that the drilling makes a big mess of my yard. How is this getting cleaned up?
By your landscaper. It does make a mess. We get it back as flat as we can, but you will need landscaping.
So if you do this system with whoever you do it, one of the things is to make sure that you're clear about the fact that at the end of it, they're going to basically put the ground flat, and then whatever you're going to do with it after that, can they talk with you about options, Mike, or how does that work?
Oh yeah, I mean, I do have landscapers that I've worked with. It'll just depend on geographic area. Whereas I can get in the truck and take my crew and go 60 miles, you could probably find a better landscaper closer than 60 miles.
Okay, so if you don't have your own landscaper, your contractor might be able to help you depending upon what your situation is and what you want to do. Do I take it that most people just throw grass seed down and they call it a day, or?
I wouldn't say that.
No.
It'll depend
Well,
on the kind of yard, the area we're digging. A lot of houses, if we're in a rural area, they have a scrub area, and that's where we'll do our digging. So when we're done, it can just be scrub again.
all right.
But if it's in the middle of your yard, yeah, you'd probably want to lay some topsoil down and have the little tiny rocks removed. Or
There we go. Thank you very much.
For
How-
years, I made the statement to the homeowners that a lot of what Eco Mike just said is just spot on. But I always told them when I leave, it's not going to be a golf course. So you will need to make it into the yard you want after we're done, because it's a disturbing process to the vegetation in the soil, and once it's in and it's corrected, you're done with it. One time, one and done.
Cool. All right. So another question here is, how deep do you have to place the horizontal borings, and how deep you have to do with vertical ones? And is it the same loop length? Great question.
that'll actually depend on the conductivity of the ground you're dealing with. So I actually used to drill horizontally when I first started, and it was just not sustainable to keep that expensive of a rig for as often as I could run the horizontal. So I got away from it. But for a horizontal bore, I'd usually go between 6 and 12 feet, because that's where my sond would still locate, and I didn't hit too much hard pan. Depends on the area you're in. Also depends on how deep you are to bedrock. Vertical, you tend to go 100 to 150 feet per ton. I like to go 150 to 175 if I can. So the loop lengths are going to be shorter on vertical because the ground is warmer, deeper, and you have less surface temperature change. It's all whatever we can do is the right thing for the job. You find out what we need to get for heat, then we figure out the most cost-effective way to get that much heat transfer, and that's the one that we recommend, because we don't get extra points for going over. We just need to get what you need.
Excellent. Thank you. How long does it take to install a geothermal system, Mike?
Generally speaking, if we're doing a ground loop, all begin to end is about a week. Just depends on how big it is. We usually separate the digging from the installation, so we have minimal loss of function time for the house. So we don't put in the main equipment until the ground loop is done. And then it's a day.
So basically about a week for the construction, but then there's sometimes permits to get and that sort of stuff and all things like that lined up, or?
Oh yeah. That's Maggie
just
does
part of
that.
it.
Yes.
Okay. Does the hot water production of the trilogy require a larger and more expensive loop? Great question.
No.
Same loop.
Same loop.
Same
Yep.
loop. And if it's cooling, you're not even running the loop.
Yep.
Aha. All right. All right. So one of the questions is, have you built any climate master home systems, and could it save money? Mike?
Have you built any?
It says, have you built any climate master home systems for 2 or
I've
4?
installed-
Oh, for 2 family homes. I see. Sorry about that. Thank you, Sarah. For 2 family homes, or 4 or 5 family homes.
Yes, I have. Matter of fact, we're doing one right now, which is not really a 2-family, but it's a home with an in-law. So with the Trilogy system, they actually have a complete zoning system that integrates with it. So you can treat the entire thing as if it was two complete systems. You put a separate thermostat over there, a separate thermostat over there, and away you go. If you're on a 2-family home, so we've done them with 4-family homes where you just build one ground loop size for the entire load, and then everybody pulls off of there. It's basically can be piped the same way as a traditional cooling tower could be on a multifamily.
Cool. And in some ways, there's some synergies by doing that, right? Because one family may be needing a little more heat, another needs a little more cooling. Is that true? That it kind of balances each other out a bit, saves some more?
It does. They all share. A BTU is a BTU. Up one is down there.
Outstanding.